Okay, just making sure that audio works. It looks like it does. Perfect. Okay. So today's lesson, or well, not really lesson, we're reviewing for a common assessment. Okay, of course, at the time of this recording, it is next Monday. So gotta get ready for that, of course. And so we're gonna do all three of our reviews right here in this one session. So we'll do the common assessment review that we did on Monday. We'll do the look at review that we have on Tuesday, and then we'll do the crash football review that we would have on Wednesday and Thursday. Okay, so that's what we're gonna do. This will be a longer video because there's so much content that's in it and so many problems that I'm gonna have to do. So go ahead and get started then. Question 1, Mr. Cruz is building a fence around his backyard. He starts by mapping out the design with the quadrilateral ABDC. Okay, so you gotta make sure that you're aware of the orientation of when, or the order that this is written in. Okay. And so the first question tells us find the slope and length of each side of quadrilateral ABDC. Okay, so before I get going, before I start finding the slope and the length, let's go ahead and label these points. This is 2, 2. This is 5, 0. This one is -1, -2. And this one's -4, 0. Okay, so that's a good start. Labeling the points is definitely something that I would start off with. Now for our slope, we can find it one of two ways. We can use the distance formula to find our, sorry, not the distance formula, the slope formula, which is the y2 minus y1 over x2 minus x2, or we just do simply rise over run. So if I do that, take this. And if my red, the part that I just marked, are my legs of a right triangle, then this is 2, this is 6. We don't know what AB is. That's what we're looking for. So set this up with Pythagorean theorem. Oh my gosh, what am I saying? We're not doing distance. We'll set this up as a rise over run. And if we have a 2 over 6, because our rise is 2 and our run is 6, simplify the slope down to get just 1/3. We'll do the same thing for AC. We do our rise, then our run. We get 2 and 3. So rise of 2, run of 3. But remember, if we go downwards, we're negative. So we're actually going to be negative here. BD, same approach. Rise over run. 2, 3, 2/3 is our rise and our run. Remember, it's going downwards, so it's negative. And last but not least, we have a rise over run for this part right here. And it looks like we're going to have the same slope as before. So 2, 6, or 2 and 6, rise over run. This is going to simplify down to 1/3. Okay. And that's our slope. Of course, you could just use the slope formula, but if you don't feel like you need to, you could just do it this way. Makes things a little bit easier for us. Then for our length, now we'll go ahead and use our Pythagorean theorem. And if we're looking for the length of AB, well, 2 and 6 here on the top left are our legs. So we'll start off with that. So AB, we're going to count it as C. AB squared equals 2 squared plus 6 squared. AB squared equals 4 plus 36. AB squared equals 40. And we can finally conclude with AB equals the square root of 40. Okay, so here I'm not too sure exactly what the questions are going to want to ask you. I don't know if it's going to be a decimal, if it's going to be a radical. It's kind of a toss-up. I would say generally best practice would probably be decimal, because I think usually they want decimals. And so if you go ahead and plug that into a calculator, let me just make sure that I have the correct number. And make sure you're rounding to the nearest third digit or nearest thousand, if we had the square root of 40, it should equal 6.325. Okay, so make sure that you get 3 decimal places. I did have to round the 4 into a 5 because the digit after that one was greater than 5 or equal to 5. And we'll do the same thing for AC, BD, and CD. So AC, we're going to use our slope, or the parts of our slope, to find our distance. 2 squared plus 3 squared equals AC squared. And I'm just going to simplify a couple steps for us. I know that this is 13 because 4 plus 9 is 13 equals AC squared. And therefore AC equals the square root of 13. And that's how I find my answer for that one. And once you get this into a calculator, you should get 3.605. But because the digit after that is 5 or greater, you should get 3.606 for rounding up. Now, it's no secret, this, of course, is going to have some congruent parts to it. So if I know that AC and BD have the same slope, right, as we've indicated beforehand, and it looks to be about the same distance, we know that this should also be 3.606. Okay, of course, I've already worked through all these problems, so I already know the answer. But you should be working through all these parts as well. Okay, and the same thing can be said about CD, 6.325. So I encourage you to work it on your own. But just for time's sake, I'm going to go ahead and fill in those parts. Okay, that's part A completed. Now part B, what type of quadrilateral this is? Okay, well, this could have multiple different answers, right? Depending on how much information you have. But remind yourself of the flowchart that we got in Unit 7, where it showed us what a parallelogram was, a trapezoid, a kite, and all that stuff. Okay. And for here, you have to reference that idea. You have to reference that flowchart in order to have a good answer for this. Okay. So if we look back, right, we know we have congruent sides, right, because we just said that the opposite sides are congruent. Right? They have the same length, but they also have the same slope, which means that they're parallel. And it doesn't tell me anything about angles, and I can clearly see that not every side is congruent. And I obviously have 2 pairs of parallel sides. So if I only have 2 pairs of parallel sides, I can conclude that this is a parallelogram. And so the way I would write this is something akin to, I don't know, I would say quadrilateral A, B, D, C is a parallelogram because this shape has 2 pairs of opposites parallel sides. I think that should be enough. Okay, that should be enough. I can't guarantee it for sure. We'll have to decide that as a collective whenever we are grading your assignments and your common assessments, I mean. But I think that should be enough. Because you're indicating you know what a quadrilateral or what a parallelogram is. You're indicating that you found that they are congruent to each other, that they're parallel to each other and whatnot. So I think you should be fine there. Okay. What is the equation of the line that forms the altitude of triangle ABD? A couple things. One, you want an equation. 2, you want the altitude. Okay, and you're working with the triangle ABD. Okay, you use point A as the vertex. And so what this triangle is looking at, just go ahead and label it. We're looking at this particular triangle. We want this triangle, and we're going to use point A to our advantage here. We know that it's going to cross BD, where there is a right angle. Where there is a right angle. But we need to figure out what the slope is. We need to figure out what point we're going to use. But luckily for that, we can find those pretty easily. So before we discuss that, we knew that the slope of BD was negative 2/3. So BD, M, right, M for slope, equals negative 2/3. Okay. Well, just choose a random letter. I chose AZ to represent my point, and we'll see what that means in a second. But AZ is perpendicular to BD, where Z is the altitude point. And so in order for me to be perpendicular with another line, right, this made-up line that I'm making up right now, in order to be perpendicular with it, I have to have the opposite reciprocal slope. So if BD is -3, I'm going to opposite and then reciprocal. Opposite means to change the sign. Reciprocal means to flip the fraction. I get a positive 3/2. And that is my new slope, my slope of AC. And so we have the slope. We know M now equals 3/2. But now we need a point. And the point is actually easier than we think. It says use point A as the vertex. And what that really just means is that we have a point to use. And so the point of A, I believe, was 2, 2. All right, let's just confirm. Right? Yes, it is. Okay, it's good to label things. Since we know a slope, we know a point, we can put this into point slope form, which if you don't remember, point slope form is y1, or sorry, not y1. Y minus y1 equals m times x minus x1. And I'm just going to plug in all my information with the variables that I have. Y minus 2 equals 3/2 times x minus 2. Now, it doesn't say to specifically simplify this, at least in this problem it doesn't. More likely than not, you are going to want to simplify, or the graders are going to want you to simplify. So I would just simplify just in case. But if it were me, this answer would have been enough because you made an equation. That's what you did. But if we were to go ahead and do that anyway, y equals 3 halves x. 3 halves times a -2. That's going to be obviously a negative. But the 2's are going to cancel out. We're going to get 3. We're going to add 2 on both sides. We're going to get plus 2 at the end. Our final answer should be 3 halves x minus 1. And that should be good. Okay. Just a reminder, do not box an answer in if you're not 100% sure that it is correct, because it will be counted as the answer that we are supposed to grade. So just don't. Okay, unless you're like 100, 1000% sure that it is the correct answer. I would just leave it alone. Okay. Now, question 2. In the diagram below, AC and LM are parallel. DBF is congruent with DFB. Okay, that's definitely some important information. Those two are congruent. If the measure of ADB is 110, which is this one, then find the following angle measures. Okay, here, what I would do, I would establish, well, obviously these 6 is what I'm looking for, but let's just go ahead and fill in the chart anyway, or fill in the table, or whatever you call it, the diagram is the better word. Fill in the diagram as much as we know. So we know that this angle has got to be 70 degrees. The reason being is that ADB and BDF are supplementary. If BDF is 70 degrees and the other 2 angles of that triangle are congruent, then I'm going to say, well, I know 180 equals all the interior angle, or all the interior angle measures of the triangle, minus 70 equals 110. And because the other 2 are congruent, divide by 2. We should get 55 as a result. So these 2 are 55, 55. like that. And if I know that BFD is 55, then I know that BFC is supplementary with it, and therefore should be 125. And from there, I can fill in the rest super, super easy. I know this is 70, this is 110. I know this is 70, this is 110, 110, 70. And I know this because of my extensive knowledge of alternate interior angles, alternate exterior, consecutive interior, and corresponding. Okay. Not too difficult. And we're going to do the same thing on the other side. So 125, 55, 55, 55, 125, 125, 55, like so. And the nice thing is here is that, well, I have every single angle already labeled, so I can just look at these and be like, oh, I know exactly what that is. So DBF, DBF is what we saw for the very beginning, 55 degrees. DJF, DJK is 70 degrees. DFB is 55 degrees. ADJ is 70 degrees. FKM is 125 degrees. DJL is 110 degrees. Okay. So as long as you measured everything correctly, you should be fine here. But the only confusion is going to be where exactly all those angles line up with and whatnot. So you got to be really careful here. Now, for question 3, something I have to iterate every single time we do a proof problem is that anytime we are told to do something, sorry. Anytime we're dealing with a proof, we always want to make sure that we write down our given into our T-chart. Okay, so looking at this, we have a given of ABCD is a parallelogram and FG bisects DB. So the very first thing, of course, write down what that just said. So my statement's on my left, reasons on my right. 1 ABCD is a parallelogram. And of course, FG bisects DB. And that is a given. I would have said in class that this is probably the more important thing to remember, because that it's going to guarantee you 1 point at the very least if you just put the given. So please just put the given. I'm going to cry internally if I notice that nobody has written it or somebody has not written it. And I bet it's going to be somebody who was not paying attention. But that's neither here nor there. And so this is actually pretty tricky, right? We know this is a parallelogram, so we know that these are congruent. We also know that FG bisects DB, which means that these two are congruent. And we just know a litany of just different angles that are going to be congruent and whatnot. It's ridiculous. Okay. So here we know that these two angles, these purple angles right here, are parallel or are congruent because they are vertical angles. And so this is kind of one of those proofs where we had to take a little bit of an unorthodox approach to it. And in fact, we're actually not even looking for a specific shape that's going to be congruent. We're looking to say that two side lengths are congruent to each other. But what else to caution here, right? Some of us will say like, oh, FE and EG have to be congruent because they're bisected. That's not necessarily the case. Okay, so unless it tells you that they're going to be bisected, or you know that one segment is something and the other segment has to be the same thing or whatever, like at that point you kind of see it, but at this point in time, there's no information for us to glean from that we could say right off the rip that F, E, and E, G are concurrent. Okay, there's just not enough information here. So kind of just expel that from your mind. But this unorthodox attempt into doing this problem, we would say, well, I have a lot of parts that may or may not help me here. And one of those parts is knowing that I have two triangles in this problem. I know how to prove triangles are congruent to each other. So let's see if I can try that. Well, I know angle DEF and angle BEG. I know that those two are congruent. So I'll give this like first thing I'd say. Angle DEF is congruent with angle BEG. And we already said that before it was vertical angles. Okay. The next thing here is, well, if I know that this is a parallelogram, I know that this has some congruent sides. Or sorry, not congruent sides, but well, that's true too, but parallel sides for sure. Particularly, I know that these two sides are parallel to each other. And I can use that to my advantage. If I know that AB is parallel and GB is part of that segment, then GB must be parallel to the corresponding part in DC. So essentially what it's saying is that if we have AB, and there's some random point G in it, if AB is parallel, then GB also has to be parallel. So let's go ahead and redraw this figure here. It's like hourglass figure kind of thing. We have DF, we have GB, and I know that this must be parallel with this one. And if I know that these are parallel, then I know I have certain angles that are parallel, that are congruent with it. And so the next thing I would say is angle EBG is got to be congruent with angle EDF. And it's going to be alternate interior. Almost done with the first assignment. And well, if we were to put this onto our original problem here, our original diagram, let's go with this color. You know, these two are congruent. Well, if I look at this, I say, well, I have an angle because of vertical angles. I have a segment because of our given. I have another angle because of alternate interior angles. Well, that sounds like a congruence theorem to me. That sounds like ASA. So if this is ASA, which it is, right? We just proved it. We would say that triangle DEF has to be congruent with triangle BEG. And that, of course, is going to be ASA. Congruence theorem. And so finally, now that we've been able to say that those two are congruent, we can say that FE is congruent to EG. And that's going to be because of CPCBC. That is the end of our proof. Okay, something to remind yourselves on is that you get a point for the given, you get a point for the correct statement and reasoning for the final step. And because of the nature of this proof, you get 2 points for the logical flow. So everything in the middle, you get 2 points. But I'm hoping that every single person will get at least 1 point because of the given. Okay, again, if you don't, I'm going to cry internally. Okay. Now, for the next set of problems, right? This is going to be Tuesday's set of problems. and this is what we're working with. Tuesday, we're going to be working with mostly transformations and trig, just because that's just kind of what we need to learn or kind of reestablish and study up on and whatnot. And so this is what I have. Okay, graph triangle PQR with vertices P4, 6, Q -4, 2, and R2, -6, and its image after a dilation centered at -4, 2, with a scale factor of 0.5. What is P prime? Okay, couple things here. Okay, definitely would graph a problem as best as you can, right? So 4, 6, P -4, 2 is Q, and 2, -6 is R. Connect those points as nicely and neatly as you possibly can. This is the triangle we're working with. And we're centered at -4, 2. I put C for center. And so if this is the problem we're working with, we got a scale factor of 0.5, a center at -4, 2. And well, we look at this and we're like, I don't know. I don't know what we're doing here, right? Some of us might think that. However, others of us may think, well, I think I can solve this. Okay, I want us to be part of those people that can think of this and say, well, I know how to solve this. So if we look here, we say we're looking for that stuff, but we're not centered at 0, 0. Okay, and that's the unfortunate part, right? We're not centered at 0, 0, so we have to actually use the long formula if we're not familiar with the long formula. Okay. And so whenever we do this, it's actually on our sheet, our reference sheet. So we can actually reference it whenever we need to. But the formula we have to use is P prime is K, scale factor, times X minus A plus A, comma K, Y minus B plus B. Okay, so it's long, but it's not complicated. We already know all the information. We know K equals 0.5. We know A is the X value of the original point, which is 4. And we know B, oops, sorry, my mistake. We know X to be the original point. We know Y to be part of the original point. We know A to be the center point, but the center X value, and we know B to be the center Y value. We should get a problem like this. Okay. And we just plug in. Get 0.5 times X, which is 4, minus -4, minus 4 at the end, times 0.5 times Y, which is 6, minus 2 plus 2. And of course, this is our P point. Those are going to add up. Well, 1/2 of 8 is 4, minus 4. 1/2 of 4 is 2 plus 2. We get 0, 4. And this is actually our answer. Okay, if you're confused on the algebra of this part, you can just ask me about it. But otherwise, we will just move right along. And so actually, our new point is going to be 0, 4, which is right here. So just in case you wanted to know, P prime. Okay, cool. Triangle ABC was reflected across X axis and then rotated 270 degrees counterclockwise to create triangle EFG, which statements below are true. Okay, so remember that if it's reflected across the X axis, right, that means that it has flipped from either the top to the bottom or the bottom to the top. So the only thing that's actually really changing is going to be the Y value. So we should have something like this. Then rotated counterclockwise 270 degrees. this is that weird rule where we had to switch them and A was negative. Okay. And so we have this, and it doesn't even give us any points, but let's just work with what we got so far and look at these certain options. Option 1, triangle ABC is congruent to triangle EFG. Well, established, do you think that's true or not? I think it's true, so I'm going to say yes. The reason why I know it's going to be true is because there's no dilation. Remember, reflection and rotation are rigid motions, so there's no change to the shape at all. There's no change to the size or the shape, rather, I should say. And so we're going to eliminate any answers without 1 as our answer choice. Triangle ABC is similar to EFG. Technically speaking, no, they're not similar because they're the exact same. So we're going to take out H as an answer choice. 3, BC is congruent to FG. And BC and FG, we know for sure cannot be correct. The reason being is that this is a mapping problem, right? So if we look here, we have BC and FG, or sorry, I misspoke then. We know that BC and FG are in the same position. Therefore, we can say that they're congruent, and therefore J has to be our answer here. Okay. Now, problem 3. If -1,9 is the original point, what is the image new point after transformation of a reflection over the y-axis and rotation 270 degrees? So this is actually mostly a carbon copy of that previous problem we just talked about, right? We said reflection over the x-axis, but now it's over the y-axis. So now we're going to change it. So -x, y instead, because the x values are changing. And rotation 270 degrees, we become a -a. Okay. And so we have our original point. Always go in the order that it tells you to do. So we have a reflection and then we have a rotation, not the other way around, because it does matter. And so if we get this, we should have -1,9 as our first point, again, our original. Then after reflection, we should have a +1,9 because only the x value is changing signs. And then we have our rotation. Rotation is going to tell us to flip and then negate. So we're going to have a 9 on -1, and that should be our answer, 9 times negative. Okay. And if you have any questions that you need to ask me, definitely can just message me whenever you need to. Fun. Problem 4. Problem 4 is pretty similar to the last problem we did, but with a little bit of a different set of transformations. Here we have a dilation by scale factor 4 about the origin and a translation of that variety. Okay, so the good thing, right, about the origin with the scale factor 4, which means we could just multiply. So k equals 4, and we're working at 0, 0. And here we're just doing some math. So we're going to take this x, we're going to decrease it by 4. So x decreases by 4, and y is going to increase by 2. And so 7, -5 is our original point. And let's go ahead and do the things. So dilation is first. Because it's just strictly multiplication, 7 times 4 is 28. 4 times -5 is -20. And then we have our translation. Our x value is going to decrease by 4, so 24. Our y value is going to increase by 2. We should have -18. And that is our correct answer here. Okay. So make sure that you get that part done. Okay. Triangle ABC has vertices A, -5, 2, B, -4, 7, and C, -2, 7. And triangle DEF has vertices at D, 1, 1, -1, E, 2, 4, and F, 4, 4. What describes the transformation that maps ABC onto DEF? Okay, now this is where it gets a little bit trickier. Okay, so you must pay attention to this. So remember that there are certain ways that we write these equations, or these letters, I should say, for the triangles. So if I say ABC and then DEF, that means that A corresponds with D, E to B, and C to F. Okay, that's how it does it. Okay, so you have to make sure that every single piece is correct here. So the first thing we'll do is we'll do A and D. A is -5, 1, 2. B is 1, -1. And so I have to establish, how did I get from A to D? Okay. And we're, instead of actually trying to figure out what we did to get from point A to point D, we're actually going to look at the answer choices to help us out here. So looking at answer choice A, it says x minus 4 as my rule for x. But if I subtract 4 from 5, I'm just going to get more negative. So that doesn't give me D. That's got to be incorrect. Well, with B, if I look at this, and B says that x has got to be negative, right? You multiply by a negative number here, or -1 here in this case. -5 times -1 is 5, but 5 doesn't equal 1, so that's not correct either. Then C and D had the exact same thing for x, which both are good. Both are actually good for us. So we can avoid x values now, but now we have to figure out our y value. Okay. And so in our y value, we have 2 for A, -1 for D, and we got to figure out, well, which one is this going to work? And so I look at this. I say C says y minus 3 is my rule. Well, if I subtract 3 from the y of A, 2 minus 3 is -1, so that is correct for D. But be careful here, right? Look at D again. -1/2 of y. If I multiply it by a -1/2 to 2, then I also get -1. So a couple things could be true at the same time. So because A and D, we can't use A and D anymore, let's use a different point. B, -4, 7, and E, 2, 4. And you can confirm if X still works, and it should, right? If we add 6 to our X values from B to E, then they do match up. That's good. But we have to figure out, well, which one of these Y values works? So y minus 3 from 7 to 4, that's correct. But if I do 7 times a -1/2, I do not get 4 as my answer. Therefore, C must be the correct answer here. Okay, so you got to really make sure that you are paying attention to what that problem is asking you. Make sure to check your work as well. Okay. This next problem, here you got to make sure that you are paying attention to what this is. This right here, this in blue, is not the notation that we are used to. Okay, because it's the notation that we are not used to, you have to make sure that you're paying attention to this part. Okay. So in this triangle, it says that there's a transformation that was applied to triangle FGH. What are the coordinates of G? Okay, well, first off, G is 1, -2 here. And G prime is as a result of the transformation that I just underlined here. But the only thing I'm going to do here is just plug in those values. So if I know that I have 1, -2 as my G, then that's going to go to G prime, which is 2 times 1 -y, -2, which is my y, plus 7. And that's all I'm going to do. I'm going to combine like terms and simplify and everything like that. I get G prime equals 2, 5. H is my answer. Okay, nothing too hard, nothing too difficult, nothing too serious. Okay. Just make things a little bit easier for yourself. We keep going. I have problem 7. Use the diagram to find cosine of x, sine of x, tangent of x. Write your answers as fractions in simplest form. This is my angle I'm looking for. If that's the angle I'm looking at, I go across to the other side. That's my opposite. Of course, the side that is opposite of the 90-degree angle, that is our hypotenuse. Okay, so make sure that you label this correctly. And 16 must be our adjacent. It's right next to us. Well, cosine of x is adjacent over hypotenuse. So that's going to be 16 over 20, which of course is just going to simplify down to 4 over 5. Sine is opposite over hypotenuse. That is 12 over 20. And that's going to simplify down to 3 over 5. Tangent is opposite over adjacent, which is 12 over 16, which simplifies down to 3 over 4. And that is our answer here. Pretty simple. Now, problem 8 is going to go over our special right triangles. Of course, these two angles right here are going to be congruent. And we're trying to find all these different variables, which is actually not as hard as you may think. Remember that if we're working with a 45-45, it is the only isosceles right triangle in existence, which means that R equals 16. We automatically know that. And remember, using your reference sheets, we know that Q is equal to A times the square root of 2. So Q must be 16 square root of 2. So make sure that you have that down. Then for our second part, we know that this is 60 degrees. We know that the side opposite of the 30 degrees is equal to A, so F equals A. The side equal to 6 or opposite to 60 degrees is A square root of 3. And we know the side opposite to our hypotenuse, or sorry, the side opposite to our 90-degree angle is our hypotenuse. That's going to be 2A. And so here we have to actually solve for A first. Otherwise, we can't get F, we can't get H. So we got to solve for A. We know 8 equals A the square root of 3. Take the square root, divide it on both sides. Get A equals the square root, square root of 3 under our 8. But of course, we don't want radicals under the denominator, so we have to rationalize it. We should get 8 square root of 3 over 3 as our A. So A equals F equals 8 the square root of 3 over 3. And if H is equal to 2A, then we're just going to multiply. So H, which is 2A, equals 2 times 8 square root of 3 over 3, which is just equal to 16 the square root of 3. Just like so. Okay, so make sure that you make that. Keep going. Problem 9, what is the value of y in triangle ABC? Well, here, triangle ABC, we need to have the geometric mean, okay, because we have some right triangles in here. Well, multiple right triangles, I should say. And here, we know that this longer piece is our hypotenuse. We know y, what we're looking for. That's our leg. And so we're going to actually use the leg geometric mean. That's going to help us here. And our leg geometric mean said that if we have A, B, C, and D like this setup, make sure you set it up correctly, make sure you label, we should get AC squared equals AD times AB. Be very careful here, okay? AC we said was Y. Y squared equals AD, which is 11, times AB. But AB is the entire segment, so we got to make sure that we add both pieces. 11 plus 5 is 16. And so we just multiply all that out. We should get y squared equals, I'm not actually quite sure, 176, I believe. Okay, 176. But remember, we still have that square root, so y equals the square root of 176. And we gotta simplify this. Okay, first off, let's just go ahead and eliminate some answers. J can't be correct and G can't be correct here. Okay, that's the first thing. But remember, we multiplied 11 and 16. 16 is a perfect square. Well, if 11 times 16 is equal to 176, I can break this up. 11 times 16, which means I can then break it up further. 11 under the square root times 16 under the square root. But I already know what the square root of 16 is. That's 4 times the square root of 11. Therefore, F has to be our answer. Okay. I'm going to move it along a little bit faster now. We have about 4 more problems left. I'll have to finish the third set of review problems just because I don't have enough time for it today. Which of the following statements are true about for triangle XYZ shown below? So sine of x, you gotta be careful here. So these little things right here, right? These are all referring to a specific angle. So sine of x is referring to this angle right here, but cosine of y is going to refer to this angle right here. Okay, so you gotta be careful. Sine of x, we look at x, the opposite side to x is 8. And the hypotenuse is 17. So 8 over 17 is what we should get. And that is correct. So we'll go ahead and circle 1. G must be incorrect. And that's it. 2, tangent x is equal to 15 over 8. Remember, we're working with tangent x. Tangent is opposite over adjacent, but not adjacent over opposite. So 15 over 8 is not correct. Okay, not correct. Because 8 is the opposite, 15 is the adjacent. Therefore, anything with 2 is incorrect. Well, cosine of y, let's go ahead and write this down because we don't actually know what it is. So let's go ahead. Cosine of y is adjacent over hypotenuse. Okay, well, if y is what we're looking at, 8 is the adjacent to y, and 17, of course, is our hypotenuse. And we said sine x was correct, saying 8/17. Therefore, oops, let me just go ahead and rewrite all of that. Sine of x and cosine y are equal to each other. And J is going to be our answer here. Okay. Last couple of problems. Solve for x, round to the nearest 10th of a degree if necessary. This problem is a inverse problem. So make sure that you set this up. If I have E with a degree of x, we know that the opposite side of that is going to be opposite. And this side, of course, is going to be adjacent. This one is like this is the hypotenuse. And so because we only have opposite and we have adjacent, we must be using our tangent. So tangent of x equals opposite, which is 57, over adjacent, which is 63. Okay, good so far. But remember, we have to look for the angle, so we must find the inverse. Remember, switch, inverse, solve. Okay, so I'm going to do that in 2 steps. Tangent, inverse, 57, 63 equals x. Then measure, or rather, x equals 42. You must use a calculator. Okay, this one says round to the nearest 10th, but otherwise you might find that you need to round to the nearest 1,000th. Okay, so make sure that you are doing that problem correctly. And the next 2 problems are very similar. Albeit you have to figure out making sure that these problems are set up the way that you want them to be set up. Okay. Do the exact same approach. With angle Q, this is our opposite. Well, obviously our opposite doesn't have anything. We know that this is the hypotenuse because it's across from 90 degrees. And this therefore must be our adjacent element. Okay, if we have adjacent and hypotenuse, we're going to be working with cosine. Cosine of x equals adjacent 8.5 over hypotenuse, which is 18. And we'll solve this out. We will get cosine inverse of not x, oops, 8.5 over 18, which equals x, and x is going to equal 61.8 degrees. Okay. Again, not too hard of a problem. Just make sure that you're doing all the steps correctly. Don't know why. There it goes. Okay. Oh, I think it cut off my last problem, unfortunately. But I do have a third problem. I should have a third problem. Okay. Well, let's see. Well, I'm going to go ahead and I guess just draw the third problem somewhere where I have space. Okay, the third problem is going to look like this. We have right angle here. We have x here. SQR. We have the values of 71 and 61. 71 and 64. So looking at this problem here, we're going to go ahead and do all the things that we need to do. So this is our opposite because it's opposite from our angle. This is our hypotenuse because it's opposite from that 90-degree angle. Therefore, this is adjacent. We don't care about adjacent though right now. Okay. If we're working with opposite and hypotenuse, we're working with sine. Sine of x is equal to 64 over 71. Simplify that down, or not simplify, but switch and inverse. You get sine inverse x equal, or sorry, not x, 64 over 71, which is equal to x. And we get x is equal 64.3. And that is 2 days worth of review in about, how long did this take me? In about 50 minutes. Okay. Fortunately, I don't have enough time to finish the other set of problems because I think that's like 20 more problems that I have to do, and I just don't have the time for that. Okay, at least not right now, maybe tomorrow. But that's what we're working with, and that's what we're going to do tomorrow. Okay, so make sure that you are studying, make sure that you are doing your best. Continue to do that Delta math work if you need to. I highly encourage everybody to do it just because that extra practice is always good. But other than that, I want you all to study and do what you got to do. Alrighty. I will see you all in the next class. Bye.